Hello there, welcome to my question of the day. This is number 10 in a series of questions I'm doing every day, posting on my Facebook page and the work solutions on YouTube. So if you found your way here from YouTube, please have a go at this question. It's taken from a UKMT Maths challenge. It was an intermediate one based or aimed at pupils in years 10 and 11 actually, so those GCSE pupils. I think year 9s can have a go at this as well. Anyway, have a go, pause while you're doing it, and I will go over the answer. Right, so I'm going to go through this question how I would do it, and I'm not saying that my method is the best at all. I'm just showing you a way of doing it. On my Facebook page, quite a few of you have posted answers which all used a load of different methods, and I'm just going to show you the way that I saw this problem. I think it's so interesting how we all see problems very differently. Okay, so this diagram shows a square of perimeter 20 centimetres inscribed inside a square of perimeter 28 centimetres. And I've got to find the area of the shaded triangle. Now, looking at the outside square, of course, this really large square that goes all the way around the edge of my diagram. I'm told it's perimeter. So I'm just going to write down its perimeter is 28 centimetres. Now, of course, that means that each side is the same length of a square, of course, and so one side is going to be 28 divided by 4, which is 7. So I've got each length of that larger square being 7 centimetres. So just popping my lengths on there. Now, if I'm looking at the square inside, it says this square has got a perimeter of 20 centimetres. So I'm going to go ahead and write down the perimeter is 20 centimetres. And so I can write down that one side is going to be 20 centimetres divided by 4, because every side is the same length. And that's going to be 5 centimetres. So I'm just going to label those sides there as 5 centimetres. And I can draw little dashes on like that to show they're all the same length. Now, I notice that the grey shaded area is exactly the same size triangle as each one of the corners. They're all right-angled triangles that are congruent to each other. They have to be, of course. They've all got the same length hypotenuse, and they're all using the same length around the outside as each other, so they're all congruent triangles there. Now, one thing that I notice is that I could find the total shaded area, and I'm going to do that by finding, first of all, the area of the largest square that I can see, which is the navy triangle, which is 7 squared, which is 49 centimetres squared. I know that I can do the area of the smaller square. Just going to write that down there, which is 5 squared, which is going to be 25 centimetres squared. Now I can see I've got 4 congruent triangles, and I've shaded all of the areas in there. So I'm going to find the shaded areas, which is made up of 4 triangles. And I know that that's the difference between 49 and 25, which is 24 centimetres squared. But because obviously I only had one of those, I know that actually the grey area, which is what I was asked to do in the beginning, is going to be a quarter of 24 centimetres squared, which is 6 centimetres squared, which is my answer. And if I go up to the question, the answer was A. I'm sure you may well have done that very differently to me, but that's the way that I did it first time I looked at it. Okay, thanks very much for listening. If you have any comments, please leave them below on my YouTube video, or make your way to my Facebook page, which is Dr. Morgan Maths Tutor. Thank you very much. Bye-bye.